Welcome all to the next video of our lecture. In this video we will see an important section, that is iron carbon phase diagram. In the previous videos we have seen some of the phase diagrams of isomorphous alloys where the solidus and liquidus are so specific. In the next video we have seen a eutectic alloy phase diagram, and we have seen how the liquidus and solidus are complicated and are shown and became so complex. Okay, and we have seen how it is. So this is next one is the iron carbon phase diagram. It is also a eutectic alloy but of a complex, very complex shape. Okay, so better understand this diagram in this format, and after this one I will give you some assignments and you need to draw the iron carbon diagram. So then the concept will be more okay, get more, and you will get more understanding. So to begin with, I need to say a few things about the iron carbon diagram. Like, it is also known as iron carbide diagram, that is iron Fe and Fe3C diagram, iron carbide diagram. Here the x-axis, okay, here you can see that the x-axis is the increasing order of carbon. Okay, you can see the composition of the carbon, but here it is not 100%, but here it goes on increasing and it stops by 6.7% of carbon. Okay, at 6.7% of carbon, this combination, this alloy is known as the cementite, is known as Fe3C. Okay, beyond this combination, beyond this alloy 6.7%, it is not interested. The engineers, material science engineers are not interested, because the weight percentage of carbon greater than 6.7 will turn this alloy into very brittle, which will not be which is not suitable to be applied in the room temperature applications. Okay, so that is the reason why it is confined to 6.7 weight percentage. So next, it is as I said before, it is a complex phase diagram, and in the diagram we can see that the iron plus 4.3% of carbon has the lowest melting point. Here, this one 4.3 has got the lowest melting point. You can see this. Okay, so here like the different phases which is present here are these: alpha ferrite, gamma austenite, delta ferrite, Fe3C or cementite, and FeC liquid solution. Okay, now let us see this figure. So it looks so complex, but it is if you understand it in a systematic way, this will be very easy. As I said before, we have the temperature on the y-axis and the percentage of some elements on the x-axis. Okay, as the weight here, the weight percentage is in the increasing order of carbon up to 6.7% of carbon, and this is known as Fe3, or it is known as cementite. And one thing you need to understand is that here we have carbon, iron plus 2.14% of carbon, we will call it as a steel, and the weight percentage higher than 2.14, we will call it as cast iron. Okay, so here the 4.3 weight percentage of carbon has got the lowest melting point. Okay, now coming to this this one again, we will see the three solid state transformations. Okay, three solid state transformation. And here the first one is 1538, or in some textbooks you can find it out 1535 degrees centigrade. First, this temperature you need to take care. Next is 1410, or like in some textbook it is 1410, here it is 1394, like slight variations will be there. And here in 910 or 912, another state is there. So actually there are three basic solid state transformations are there. Okay, because after this one we will have a phase change. So here we can see various phases as we discussed before, as we discussed here. So these phases we can see in the next slide. So this is the various phases. Here we have the delta phase. Here we have the delta plus the liquid phase. Okay. So throughout here, this is the liquidus, that means above which we have your liquid. This phase is known as gamma plus liquid phase. Here it is iron carbide plus liquid phase. Okay, so this small portion we can see that it is delta plus gamma the phase, and here it is totally pure gamma phase. Moving crossing this line, we will have alpha plus gamma phase, and here it is pure of alpha phase. And here we have another like alpha plus iron carbide phase. So like major phases are this one, alpha phase. Here it is Fe3, here gamma, here liquid, and here we have delta. So this intermediate phases, like this one is delta plus L, this is delta plus gamma. Here it's the intermediate phase of this gamma and L phase, so it is gamma plus L. Here it is the interface between liquid and iron carbide Fe3C, so this one is Fe3C plus L. And here it is the interface between, this is the interface between gamma and L, so we have gamma, sorry, not Fe3C, so gamma plus Fe3C. Here this is the interface between alpha phase and Fe3C, so it is alpha plus Fe3C. So like I request all students to by heart this particular combination and particular diagram. Somehow you need to study this one, and like the weight percentages you will get it from here for the corresponding. So like we can see one by one each phases. So the first one is alpha ferrite. Okay, this one exists at very low temperatures and in the low carbon content. So this is alpha phase, which exists at the very low temperature and the very low carbon percentage. So alpha ferrite is a solid solution of carbon in BCCF ion. So this phase is stable at room temperature, and this phase also be magnetic beyond 768 degrees centigrade. So somewhere here, somewhere here, it will turn into magnetic. Okay, from somewhere here to here bottom, it will turn into a magnet. So next is the delta ferrite. Okay, this phase has a similar structure as that of previously discussed alpha ferrite, but it exists only at high temperature. So let us see where we have the delta phase. So this is the delta phase. We can see that it exists at higher temperature. So the phase can be spotted at the top left corner as we shown before. and has a melting point of 1538. So it is around melting point is 1530. Sorry. So next is the iron carbide or cementate. Cementate is a metastable phase of the alloy with a fixed composition of Fe3C. That means it is occur only at 6.7 percentage. That means 6.7 percentage. At this point, it will turn into iron carbide. It decomposes extremely slow at room temperature into iron and carbon. And cementate is very hard as well as brittle. You can see that beyond this combination, the total alloy will become pure brittle material. So it will show some nature, some reasonable brittleness and hardness. Okay, so this makes it suitable for strengthening the steels. Its mechanical properties are a function of its microstructure, like grain size and crystal orientation and all, which depends upon how it is mixed with the ferrite. Okay. Then alpha and delta ferrites, how it is mixed. So this part is very critical. Next is the Fe iron carbon liquid solution. So solution part, actually we have what we have shown is on the top, that is iron and carbon. It's pure liquid state beyond this one, this white portion. Okay, it is seen in the upper region of the diagram. As the name suggests, it is a liquid solution of carbon in iron, and as we know that delta ferrite melts at 1538, it is evident that the melting temperature of iron decreases with increase of the carbon content. With increase of the carbon content, we can see that the temperature, melting temperature of this iron is decreasing. So these are the basic different important phases in our iron carbon diagram. Once again, I repeat it. That is delta phase, important phases like delta, L, gamma, alpha, and Fe3C. So these are the intermediate like combinations, like alpha plus Fe3C, gamma plus Fe3C. So here we have gamma delta plus gamma. This is delta plus liquid phase, and here it is alpha and gamma. So here it is iron carbide plus liquid. So such phase intermediate phases we can also see. So some of the important reactions which happens in iron carbon system is this first one. This is occurs at 1493. We have shown by a straight line here. If you observe, you can see 1493 degrees centigrade. That is peritectic reaction. So here the delta plus liquid is converted into this gamma phase and vice versa. Next is the eutectic reaction. So here this occurs at 1147. Here the liquid phase is converted to gamma plus iron carbide. Third is eutectoid, that means which occurs at 727 degrees centigrade, where the gamma phase turns into alpha plus iron. So these are the important reactions which is seen here. So this is what all the iron carbon diagram tells about. So thank you for the attention, and so I think by this we finish the phase diagram topics, and in the next videos we will see about the various fracture mechanics, small slight fundamentals about fracture mechanics. So thank you for your attention.